All right, we're going to look at systems of equations. And in this case, we're going to be talking about linear equations. And remember that a linear equation makes a line. So if you look down here, we have two different systems. We have this one that I'm circling here, and then this one. And when you graph two linear equations, most likely they're going to cross at one point. But we have two other possibilities, and let's take a look at that. Let's say I graph two lines like this. Now you can see that these lines cross at exactly one point. So there is one point that they both have the same x and y value. One and only one point if they look like this. Now we have two other possibilities. One other possibility is this. These two lines are parallel. Parallel lines never, ever cross. So they share no points together. And then we have another possibility. Here's a line, and here's the next line. Did you see it? It's right on top of the first line. So these two lines, if they are right on top of each other, they say that these two lines coincide. Now most of the systems of equations that you're going to see with two lines are going to look like this. They're going to cross at one point, and you're going to have an answer that looks like an ordered pair. But you will run into the other two possibilities. You will run into these two parallel lines, and when they ask you what's the solution to that, you're going to say that these have no solution. You may also see it written as empty set. It may use the words empty set, or maybe even you see this symbol here. Now, if your lines coincide, you're going to ask yourself, what points do they share? What points do they have in common? Well, they have this point in common, and they have this point in common, and they have this point in common, and this point, and this point, and this point, and this point. So can you list all of the points that they have in common? No, you can't. So this is infinitely many solutions. Infinitely many solutions. Now, one way to find the answers, to find the solutions, is to actually graph the lines, and you can use your eyes to inspect and say, oh, let me look. Let me find out what that point is here. Or you can look and use your eyes to say that there's no solution, or you look at your graph and you see that there's infinitely many solutions. So one way to solve a system of linear equations is to graph them. But we have two other methods that we're going to look at. The other method is going to be called the addition method. Okay, it's also called the elimination method. Addition, and I'll write up here elimination. And this system right here is set up really nicely for addition. If you added these two together, you're going to notice that you get 2x, and then y minus y will cancel out. From there, you can solve for the x. Once you know the x, you can plug in and you can solve for the y. But these are set up for addition because they're right on top of each other, and adding them right now is going to have one of your variables cancel out. The other way we're going to solve is going to be called substitution. And if you look at these two equations, these are set up for substitution because this y is already solved for. And I could take this y and I can plug it in right there for this y. And when you do that, you'll be down to one variable, one equation, one variable. You can solve it. So 3 different ways to solve your system of equations: graphing, addition, or substitution. And they're going to tell you specifically how to solve it. Most of your answers are going to look like this right here. They're going to be an ordered pair, an x and a y. Sometimes you're going to see no solution if the lines are parallel, or you may see infinitely many solutions if the lines coincide.